Okay, so welcome to this session 4. So in this session, we're going to discuss on these two topics, that is OpenGL Polygon fill area functions and Polygon primitive constants. Fine. So now so far we will see what exactly we are discussed. So if I see all these topics, whatever we have discussed with respect to polygons, so this is the prerequisite what is required to understand this particular session 4. Hence we are trying to build from the basics of polygons till where we are going to talk about the fill area primitives, what exactly the type of polygon the fill area is going to work upon, and how exactly we are going to convert any complex polygon or a concave polygon into the convex polygon which the OpenGL can easily handle. And so this is what the whole topic from the session 2 and session 3, it is somewhere we are trying to describe or trying to discuss with respect to polygon fill area primitive. And even right now this session is going to be upon how exactly we are going to fill the polygon area and what the functions we are going to have. And that is what the OpenGL Polygon fill area functions is going to be. What sort of functions the OpenGL is available and how we are going to use those functions. With respect to that, there are few polygon primitive constants. Instead of saying few, there are exactly 6 polygon primitive constants. So which you can make use of those primitive constants whenever you want to handle or whenever you want to draw or whenever you want to display a polygon on a display window. Hence we will see exactly what is all this going to be. Hence the OpenGL Polygon fill area function. Now what are the functions available right now in your OpenGL to handle a polygon or to draw a polygon as a basic primitive? So now this is similar the way we have drawn a point or the way we have drawn a line or the way we have drawn a polyline. It is similar. The way we do this, it is similar to the what all we have done until now. So and as I discussed about the basics of polygon, a polygon should have a well-defined interior. Hence by default every polygon in OpenGL is going to be filled with solid color. It's by default. Later on you can think about what you should do with the interior, but right now stick on to the default that the interior of a solid or a interior of a polygon is going to be filled with a solid color. So now with this, as I told, is similar to drawing a point and a polyline. That means if you remember how exactly we were drawing a point or how exactly we were drawing a polyline, yes, using the pair of GL begin and GL end. That is what exactly even we are going to do in this session again with respect to whenever we want to handle a polygon. Hence we are going to have again the begin and the end pair, and you remember the begin takes some parameter, that is the type. If I want point to be drawn using the set of vertices what I give between these two begin and end, though those will be used as a points if I mention the type as GL points. If I want a line, I am going to put it as GL line. If I want a line loop, if I want a line strip, with respect to that I am going to put exactly what type of primitive structure right now I am going to display. Fine. So now we will just see how exactly a point or a polyline or a line and the polygon is going to differentiate itself using the same set of pair GL begin and GL end. Hence, so now we will even see how the GL point is going to work. If the type is going to be GL point, how this is going to work, and if the type is GL lines, how exactly it's going to behave, and if it is GL line strip, how it's going to behave, and GL line loop. So all this 4 you're already familiar with. You should clearly know how this 4 is going to be working when I pass GL points as a parameter for GL begin or GL lines as a parameter for GL begin, and so on. Hence the new constant for GL begin what we like to introduce is GL polygon, and so this should be the new type or a new constant for you right now. But all this for your already experience, but still as a recap or as a review to exactly compare between how a polygon is going to behave with the same set of points or same set of vertices using same GL begin GL end, and we will just go through this. So right now if I am going to execute this GL begin and GL end with 0 vertex, it is clear enough, nothing is going to be displayed. That is what exactly you are going to see. There is nothing to display because even there is no single point or single vertex enclosed between the GL begin and GL end. So now what if there is one point? What happens now? I am using GL vertex 2f of P1 between GL begin GL end. Now the type is GL points. If the type is GL points, you can see there's going to be one point on the display depending upon what attribute you set, what the size of the point, what's the color of the point. Irrespective of that, I'm going to, or I'll be able to draw a point on the display window. Fine. So but look at this, if there's one point, nothing is going to be with respect to GL lines. Nothing will be drawn if the type is line strip, nothing will be drawn with the line loop, and again nothing will be drawn with the polygon again. So now we will see with the 2 points. So what if I am going to have 2 vertices? So now again observe the difference. I am going to display 2 points and I am going to draw a line, one line between the P1 and P2. Again the same output, 1 point between P1 and P2, and again still 1 point or one line over here between P1 and P2, but it's a line loop. In the line loop, as we already discussed, I should start with P1 and P2, draw a line and loop back and draw one more line between P2 to P1. Yes, it is happening. P2 to P1, there is another line has been drawn, but as one is overlapping over the other, you're not able to visualize those 2 lines. But look at this polygon, there is still no any output if you are passing GL polygon as the type with the 2 vertices or the 2 vertex. Is it clear? So now what if I'm going to have 3 vertices then? So now you can see I'm going to have 3 points here as usual. I'm going to have only one line because 1 and 2 has been used to draw the line, and for P3 there is no its pair vertex, that is there is no P4, and so nothing will be drawn. There's only one line. In GL line stream, P1 to P2, P2 to P3, and so I'm going to have 2 line segments, and a line loop P1 to P2, P2 to P3, and again P3 to P1. So this should be quite clear enough for you. And now look at the polygon, something has appeared over here. And so when I am going to have GL polygon, now I am going to have, it is similar to GL line loop. That is P1 to P2, P2 to P3, P3 to P1 is the outline of your polygon. And as I mentioned, by default the interior is solid color. Whatever the color you have set before executing these statements, that color will be used to fill the interior as a solid color. Right now, as per my example, it has been set to color red, hence you are going to see red solid color displayed as the interior of your polygon. Fine. So now this means, and one more important point, what you should note it down here is, whenever you want to have a polygon, you need to have at least 3 vertex, 3 vertices, 3 points. If you have less than 3, the GL polygon will display nothing on your display window. Is it fine? Hence have a clear clear, good enough information of what's the difference between GL points, line segments and the GL polygon. It is same. The only difference what you're doing is the type what you're going to use, the type what you're going to pass. That is the one thing which is going to make the difference. So now I'm going to have fourth point. Again, I'm going to have a polygon here, and remaining all this is self-explanatory. And there's going to be one more line in GL lines, because for P3 now there is a paired P4, hence I'm going to have one more line segment here. Now this is going to be how exactly we are going to display a polygon using the basic primitive. Is it fine? And remember, the polygon requires at least 3 points. It can be any number of points here after, but it should have at least 3 points. Fine. Now just observe here. Fine. So at this point you know how to draw a polygon, and so I have just replaced the type with GL polygon. Now when I execute this with the 4 points, so P1, P2, P3, P4, and I have got an polygon with an solid interior with the color red, and this entire thing we call now this as single polygon. So now just observe this one more code chunk what I am going to put here, and observe what's the change here. Just observe what's the change between this two. Compare and just observe. Yes, whatever the statement have been marked with red color, just observe this. It was P2, P3, P4, and right now it is P4, P1, P4, P3, P2. Now what this difference is going to make? What difference it makes? Now just observe here. Just observe here. Fine. So now I am going to have P1, P4, P3, P2. Yes. So now just I am starting from P1 to P4, P4 to P3, P3 to P2, and again P2 to P1. Now just observe the direction what I am going through. It is clockwise direction. Yes, it is clockwise direction. In this case, I have started with P1 and then P2, P3, P4 back to P1. Hence it is an anti-clockwise or counter-clockwise direction. Hence now whenever going to give a polygon, you can maintain any direction, either clockwise direction as in this case, or an anti or an counterclockwise direction as in this case. Hence, so right now I'm going to have a counterclockwise direction, and I'm going to have clockwise direction. Now what difference it makes? Both are same polygon, both are similar polygon. Yes, as a viewer, as an viewing of this object, as I look at the object, both are similar. There is no any difference. But programmatically and technically, if I look behind the scene, there is a difference. The difference is, if you are giving the points of a polygon in a counterclockwise direction, this will be treated as a front face, and if you are going to give it in clockwise direction, this will be treated as a back face. And so clearly understand whatever the object you are going to display on a graphics window using OpenGL, any object, it can be 2D or 3D object, every object will have the front face and the back face. Whatever the face right now it is visible for the user, we call this as front face. Whatever is hidden behind the front face, we call this as a back face. Hence, whatever the object is going to be, remember, is going to have both the faces. So now the order or the direction what I am going to give of the vertex, this is going to differentiate between the front face and the back face. So right now you need not much bother about this. So we will discuss about this direction properties and the front and the back face in the coming classes, but right now just remember what makes this difference. Hence the direction will matter now. Is it clear? So now the next property is, now just look at this one more change what I'm making. Now just observe the change with the previous code and this code, what is going to happen. So P1, P2, P3, P4, it's still same. Oh, something is changed over here. So right now I'm going to have P1, P2, P4, P3, and now again don't look into direction. Don't look into whether it's clockwise or anti-clockwise or counterclockwise. So now this, the difference here is, just look at this. When I'm going to have P1 and P2, it's P1 and P2, both are same. I'm drawing an edge between P1, P2, and I'm drawing an edge between P1 and P2. There's no much difference here. And the next edge should be yes, P2 to P3. And in this case, P2 to P1. Yes, that's the one difference. Yes, I'm going to have P2 to P3 here, and I'm going to have P2 to P4 here. And the next edge between 3 and 4. And in this case 4 and 3, and so 3 and 4 and 4 and 3. Fine. Now just observe, though there are same 4 points or same 3 points until now, and you can just observe the difference here. Fine. So this is the outline until this point of time what I got, and this is the outline what I got until this point of time. I'll just tell you what difference is going to make. So the last edge what I should draw here is from P4 to P1, in this case P3 to P1. Fine. Now this is the outline of your polygon, and once you have got the outline of a polygon, so your OpenGL by default will fill this with the solid color, and this is going to be the polygon now. Now just observe what has happened. My intention was to draw a square or a rectangle using 4 points. Fine. This is working perfectly. But now just look at this. This is not so. This is not working as I thought. So this is the one mistake what we usually make. It may not be intention. It may be the mistake thinking. We can give it any order. If it is a triangle, if it is about 3 points, you can give in any order. The order will never matter, only in the case if you are trying to draw a polygon only with 3 points. Anything over that, starting from 4 points to n points, so make sure you give an extra care on the order. If you don't, if you miss the order, this is the problem what you're going to encounter with. So this may be not the output what you're expecting, because you're expecting a simple rectangle as a simple convex polygon, but you are ending with a complex polygon. It's going to end with a complex polygon. Is it fine? Hence, that is what even the order is going to matter. The direction is going to matter to front face and back face, and even the order will matter, so that you take extra care that you're not going to get an unwanted structure of your object. Fine. So now with this OpenGL fill area function, now just observe here, I'm going to have a polygon, the same polygon. Now I'm just trying to represent in a different way. Until now I was just saying 0.1, 0.2, 0.3, 0.4, and we are aware that a point is made up of x and y value, and that is what I'm just doing. I'm just replacing p1 with x1 y1, x2 y2, x3 y3, x4 y4. So similarly over in this case, so instead of using p1 in general, I am passing the parameter as x1 y1, x2 y2, x3 y3, x4 y4. Hence I am just going to give the values of the axis rather than just as a point. And so remember, so this is the way we are going to give the points. Until now we were just discussing generally. So now I have just replaced this with x and y, and so now with this points we are just going to have this x1 y1 is same, and now just observe we had x2 and I'm replacing y2 with y1. So just wonder why, because yes, now just if you observe this, if this is y1 and if this is a straight line, don't you think so this is still y1. Yes, because the line is still on the same value of y-axis. It is not moving up, or even it is not moving down. It's still in the same axis or the same value of y. It is not up or it's not down. Hence, rather than calling this as y2, I am going to use the same value of y here. Hence, I call this as y1. And if this is x2, rather than calling this as x3, so this should be called as x2 itself, because on the x-axis, x is still same. I am not either moving towards left or moving towards right. It's still in the same x value on the x-axis. Hence, if this is x2, even this can also be called as x2 rather than x3. And now this should be y2 now, because if this is y1, I am moving above, hence it should be y2 now. It cannot be y1. And with the same, I am going to have y2 here. And if this is x1, even this is going to be x1. Hence, so instead of using the same value repeatedly, what I have done is, I have done a smart work over here, where I am replacing the duplicated value with the same variables. That's it. That is the only thing what we are doing here. That's fine. So by doing this, instead of having 8 values, now I am going to have only 4 values: x1, x2, y1, y2. That is x1, y1, x2, y2. The two corners. Now just observe the two corners which are diagonally opposite, we can use to draw any rectangle. Even it can be a square. So if I know the two corners which are diagonally opposite, I can draw a rectangle. Fine. So with this, I have modified over here. So I am going to have x1, y1, x2, y1, x2, y2, x1, y2. This is the one change what we are going to do here. And with this information, we are going to have a special function just to draw rectangles. Fine. You don't have any OpenGL function to draw a triangle. You don't have any function to draw any other polygon other than GLRectangle. And so now we are going to have GLRect is an API which is used to draw an rectangle. And so now if you just observe, this takes 4 parameters: the x1, y1, one corner of your rectangle, x2, y2, exactly the opposite, diagonally opposite corner of x1, y1, that is x2, y2. So with this 4 values, your API GLRectangle will make sure it's going to draw a rectangle. Hence hereafter, if I want to use GL, or if I want to draw a rectangle right now, you need not use all this codes. You need not use GLBegin and the constant GL polygon, the 4 vertex and GLend. You need not use all this. Just replace this set of 6 statements with one statement called as GLRect. This will do the job for you. And remember, this API is used only to draw a rectangle. Is it fine? Hence, now using this function, I am just going to have x1, y1, x2, y2. So right now this star, it's not the function name. The star is not a function name. If you remember, when we were discussing about GL vertex, we had something called a GL vertex star. So star was supposed to be replaced with 2 or 3 characters. Right now I have replaced star with 2 characters, something like 2f, because it's taking 2 values, and f because it's going to take a floating point value. Now in this case, the star should be replaced with, so now don't use this as 2. So it is not like 2, because it always takes 4 values. Because rectangle is always a 2 dimension, it is meaningless to say I am going to say it as GLRect2. The only thing is what value it takes. Either it takes integer, or it takes floating point values, or double, or short, what type of value it's going to take, I can mention. Hence I can just use GLRect F. And with this, if I'm going to pass this as an array, if I'm storing this 2 as an array value, something like P1, and if I'm storing this as 1 point as P2, even that can be done here. If I'm passing an array as a parameter, now I need to use second character, that is V. Hence now this star will be replaced with I if I am passing integer values of all this x1, y1, x2, y2. But now I'm not using any arrays or vector here, hence I'm just using only GLRect type. And if I am passing a floating point values for this 4 values, it's going to be GLRect F. And if I am passing a integer with an vector array, I am storing x1, y1 in v1 and x2, y2 in v2. Then I am going to have GLRect IV. I stands for integer, V stands for vector. And I am going to have GLRect FV, similar to the floating point values. That's fine. So this is how we are going to make use of GLRect function. So now just this is going to be an example. I have just replaced x1, y1 with 10, 10 and x2, y2 with 20, 20, and similarly these two corners. And so now I just need to pass this as a parameter now, because this is integer, and so I'm using I. I'm not using any array here, and so I'm going to use 10, 10, and I'm going to pass x2 and y2 as 20, 20. Just an example how we are going to use a GLRect function. And remember, when you use this function, do not put this function inside GL begin GL end. The entire block should be replaced. Fine. So now with this, if I'm going to pass an array, something like I'm going to store the vector 1 v1 of 2 as 10, 10 in the form of array. Instead of having this as x1, y1, I'm putting this as v1. This is now x1, this is becomes y1. Similarly for x2, y2. If I'm storing it as an array, so use GLRect I, because these are integer, and I'm going to pass array as a parameter, hence v1, v2. Right, so this is how we are going to make use of GLRect function. This OpenGL Polygon area fill function, which is going to help you to only draw a rectangle, or which is special case is going to be a square. Fine. So okay, so now we are going to discuss upon the primitive constants for polygon. And as we have already seen, what is GL polygon is going to do with the primitive constant, the parameter what I am going to pass for a GL begin. Along with this, I am going to have remaining 5 constants, primitive constants, which is going to help us in having a polygon as a primitive basic structure. Hence we will see what exactly this is going to behave, or when we should use this along with GL polygon. So now we will discuss about the triangle, then we will discuss about the quads. Fine. So now whatever the polygon we are going to develop using any of these primitive constants, remember it's going to be a single fill polygon. And if I'm going to use either GL triangle or GL quads, I may end up with set of unconnected fill polygons. Even though they are unconnected, still they are be treated as single polygon. And we are going to have a set of connected fill polygons. Hence the set of polygons can be unconnected or set of polygons can be connected, but still it is a single fill polygon for us. Is it fine? Hence one single polygon can have n number of parts, or it can be of n number of sections or n number of sectors. And so now we will see how exactly this GL polygon and GL triangles, GL triangle strip and GL triangle fan is going to behave when I am going to pass as a parameter for GL begin. Now you are already aware how the GL polygon is going to work, but right now try to compare how the GL polygon will behave with the remaining 3 type of constants. So right now there are 0 vertex, hence nothing is displayed on the Windows screen with all these 4 types. Is it fine? So now I'm just going to have one vertex now. Hence I'm going to have P1. The P1 is not present. Still you can see there is no polygon drawn. Yes, because you need to have at least 3 vertex. If there is no 3 vertex, none of the polygon is going to work. Even not this 3, even this 3 is also a variant of polygon, hence nothing is drawn. Hence I mentioned here, there are 0 parts in this single polygon. Now if I am going to have 2 vertex, still nothing has been drawn, because at least I require 3. And now when there is the vertex 3, so you can see I am going to have a triangle here. P1 to P2, P2 to P3, P3 to P1. The same thing here. When I am going to have GL triangle, again I am going to have P1 to P2, 3, 1. Again the same. Hence I am going to have only one part over here. Hence I am just going to have a polygon. In this case, when I pass 3 vertex, all the 3 constants are similar. It works in similar way. Now when I'm going to have the 4th vertex, just observe, when I'm going to have 4th vertex, this is the difference. Fine. So now it was triangle with 3 vertex. Now it is going to be a quadrangle. Fine. I'm just going to have a quadrangle now. P1 to P2, 3, 4 and 1. And now when I say GL triangles, it is still a triangle now. So now 4th point is existing here, but it has been not used because the first 3 points has been used to draw a triangle, and to draw second triangle it needs 2 more points. Hence nothing is displayed using the 4th point. And if you look at GL triangle strip, the first triangle was between P1, P2, P3 back to P1. Hence 1, 2, 3 was the first triangle. The second triangle will start from P2, P3, P4. That means in the previous 3 vertex what I used, it is going to use the previous 2 vertex from the previous set and adds one more new vertex. It every time adds one more new vertex with the previous 2 vertex of previous set. Hence from the previous set was P1, P2, P3. The 2 previous points of the previous set is P2, P3 and add one more P4, and this becomes P2, P3, P4, the triangle between these 3. And this is going to be the GL triangle strip. And now just observe in the GL triangle fan. In GL triangle fan, so P1, P2, P3 was the first triangle which it had drawn. The second triangle is P1, P3, P4. That means the very first vertex will be always one point of the triangle. This will be the constant point for every triangle what I am going to draw. Hence I got 1 point to draw a triangle. And from the previous set, that is 1, 2, 3, the latest point will be taken as the second point and adds one more new point. Hence the common point P1, a previous point from the previous set, that is P3, and a new point P4. Hence I am going to have P1, P3 and P4. So now let me add and just observe here. I am going to have only one set of polygon in GL polygon, only one set of polygon in GL triangle. Now I am going to have 2 polygons here. One polygon from P1, P2, P3, the second polygon from P2, P3, P4. And in this case also 2 polygons. So you can just see what are the 2 polygons or 2 set of polygons what I am going to have. So now I am just going to have 5th point now. So if I am going to have 5th point, now you can see I am going to have a pentagon here in case of GL polygon. And in GL triangle, still there's only one triangle, because using P4, P5, I cannot draw a triangle. I need 3 points. Fine. And still there's only one triangle. But whereas in this case, earlier I had 2 triangles. So the new triangle is going to be, so now P5 is the new point. The previous 2 points are 3 and 4. Hence using 3, 4, 5, I'm going to draw a new triangle. and in this case P1 is a constant point, P4 is the previous point, P5 is the new point. Hence I'm going to draw the triangle between these 3 points. So now I'm going to have 3 sets here and I'm going to have 3 sets here. Fine. So now what if I'm going to have 6th point? So hence I'm going to have a hexagon here, and now just observe, I've got 2 triangles now. The first triangle between 1, 2, 3, the second triangle between 4, 5, 6. That is how the GL triangle works. So now there are 2 sets here, but GL polygon still 1 set, hence it remains constant. Whatever the point you give, it always creates a structure, a polygon structure using all those points. But in this case it always try to create triangles. Fine. And again, so now you can understand how I got this triangle and how I got this triangle using GL triangle fan. Now this is the difference between this set of primitive constants for polygon with respect to triangle. And observe, all these 4 are still single polygon. So though these 2 are unconnected fill polygons, but still this 2 is going to be single polygon. And even this is set of connected polygons, this is set of connected polygons, but still this are one polygon. Anything comes between GL begin, GL end, this entire structure what has been made using this 6 point is one polygon for me. I can call this as parts or I can call this as sections, but still this entire thing is one polygon. This is one polygon, this is one polygon for me. Is it clear? And so now once we are going to use this, you can see this entire thing will be filled. You won't see any edges, you won't see any edges which is going to be with the polygon. Only you're going to see the interior, no edges will be seen by default. Hence you cannot differentiate which is the first polygon, second polygon, third, fourth, which is the first triangle here, second triangle. Hence this is entirely one polygon for us. Hence this is how this constant is going to work. It's fine. So now at this point of time, I hope you're clear enough how GL triangle works and GL triangle strip works and GL triangle fan works. So now we'll just look into GL quads and GL quad strip along with GL polygon. Fine. So now just observe here, we're going to have GL polygon, GL quads, GL quad strip. This is the 2 new constants which you want to understand, but I'm using the same old constant again, the GL triangle strip, which we have already seen, already have learned how this is going to be. I've just put it over here just to make the comparison between quad strip and then triangle strip. Is it fine? So now we will just see how this is going to behave with this constant. Again, I'm going to have GL begin, the type can be any one of those. So right now I'm going to have GL begin, GL end with 0 points, nothing is visualized. I'm going to have 1 vertex, again nothing is visualized. I'm going to have 2, nothing is visualized. As soon as I got 3rd point, now you can see there is a triangle here and even there is a triangle here. Hence I got 1 part over here. But if you observe, this is still 0, nothing has been visualized, because when I say quads, it deals with quadrangle. That means, yeah, at least you require 4 vertex or 4 points. Hence, right now, you're going to visualize nothing in these 2 cases. Now, when I'm going to have the 4th point, you're going to have a quadrangle here. So just to keep this as simple, I have just changed the position of P1, P2, P3, P4 in polygon, but the P1, P2, P3, 4 I have kept intact with these 3 cases just to reduce the complexity. If I don't do this, if I use the same positions, I am going to get a complex polygon in this case. Hence, just to keep the discussion simple, I have just altered or modified the positions. So irrespective of that, I'm going to keep all this going to be the same position. And now observe, right now in the polygon I have got quadrangle with the 4 points with a different structure due to different position, and GL quads I'm going to have 1 quadrangle using the 4 points. So it's easily understandable. And GL triangle strip, as I've seen, so 1 2 3 the first triangle, 2 3 4 the second triangle. That is, from the previous set take out 2 points and add 1 more point. That is what the triangle strip works. And in the quad it's similar to triangle strip. So from the previous set take the two previous points, and I'm going to add the 2 more previous points. I'll just show you what exactly you mean by this, but right now I'm going to have only one quadrangle. These two are similar now, but I'm going to have 2 parts here. Still I'm going to have one part here. So now what if I'm going to have the 5th point? I'm going to have a pentagon here, and the 5th point is not used, because to draw a quadrangle you need 4 points. The 4 points already has been used. I got left with only 1 more point. Using only 1 more point you cannot draw a quadrangle. You need 3 more points. Even the same case over here. Hence I got left out with only 1 point. I cannot draw any quadrangle. Whereas in this case, so I am going to have a new triangle from P3, P4, P5, the 2 previous points along with 1 new point. Fine. So now I'm just going to have 1 more point now, P6. So now I'm going to have a structure here, so you can easily understand how this is going to behave. And in this case I've got 2 points. I cannot not yet draw any quadrangle, and I'm going to draw a new triangle, that is using previous 2 points and 1 new point. Oh, now just observe here, I've got a new quadrangle. So how did this happen? Now just compare this between these two. So now to draw an triangle strip, I will take the previous 2 points from the previous set and add 1 vertex. The GL quad will take the previous 2 points from the previous 2 vertex and it takes a new 2 vertex. Right now in this case, the previous quadrangle what was drawn was P1, P2, P3, P4. Yes, now this becomes the previous set. So from the previous set take 2 vertex 3 and 4, and I'm going to have 2 new vertex 5 and 6. So using 3 4 5 6 3 4 5 6 I'm going to draw a new quadrangle. And so now if I'm going to have a 7th point, now you can clearly understand this, and there are only 3 points, hence I cannot draw any quadrangle over here. And I have left out with only 1 more point. I cannot draw any quad strip also. If I add 2 new vertex, if there are 2 vertex remaining, only then I am going to draw a quad strip. Fine. So now if I am going to have P8, I am going to draw a new quadrangle and a new triangle and a new quadrangle over here. So P4, sorry, 3 4 5 6 was the previous set. From this previous set, P5 P6 becomes the previous vertex. Add 2 more vertex and draw the quadrangle. Fine. So this is how this is going to work. So hence I'm going to have 3 quadrangles here. I'm going to have 6 triangles here as a set, but still it's 1 polygon, and I'm going to have 2 polygons over here. Fine. So this is how the GL quads, GL quad strip, and so on. And again you can just see the GL quads is going to draw an unconnected fill polygons. Fine. And this is how this is going to work. The constraints in OpenGL is going to work. And as I told you, so no edges will be displayed. This entire thing becomes 1 polygon for us. And so this is going to be all about the GL polygon, triangles, the triangle strip, the triangle fan, GL quads, and GL quad strip. Fine. So now whenever we are going to talk about parts, I just told you GL polygon will always give me only 1 part using all the vertex, and in the GL triangle it is going to give me unconnected sets of polygons. If I talk about GL triangle strip, it is going to give me connected set of triangles. Again, connected set of triangles. So now I should know what is the size of this set. Depending upon number of vertices, that's n vertices, what is the set size for the different constant perimeter is going to be. As we will just look into this. If it is GL polygon, it's always 1. I'll be having only one set of polygon. There is nothing called as connected, there's nothing called as unconnected. If it is 3 points, I get a triangle. If it is 4 points, I get a quadrangle. If it is 5 points, I'm going to get a pentagon. Hence, whatever the n value is going to be, I'm going to always get only one. The set size is going to be only 1. If it is triangle, it's going to be n by 3. If it is going to be n is 3, I am going to have 3 by 3, which is going to be 1. Hence, I am going to have one set. The set size is going to be 1. And if n is 5, 5 by 3, which is going to be around 1 point something or 1.67. So, which I am going to round up to 1. Round up to 1. Again, I am going to have only one triangle. If this is 6, next I am going to have 6 by 3, which is going to be 2. I'll be having two triangles. That is, the set size is going to be 2. So, in similar way, to know how many set this is going to contain, I am going to have n minus 2. The formula is n minus 2. Similarly, I want you to find out what is the formula for GL triangle fan. And for the quads, similar to n by 3, I am going to have n by 4. And even now, I want you to find what is for GL quad strip. Is it fine? So now, with this, for example, what if n equals 1? It is what the set size GL polygon is going to be? S. It is going to be 1. The size is still 1. Whatever the value of n is, the size is going to be always 1 in case of GL polygon. What in the case of GL triangle? So I should divide this 11 by 3. Which is going to give me 3.667. Whatever this value is going to be, I need to just discard this decimal value. Hence, I am going to have 3 triangles. Hence, the size is going to be set of 3 triangles. The set size is going to be 3 triangles. And similarly in this, so 11 minus 2, that is line. The size is going to be 9. Similarly, I want you to find it out for GL triangle fan for n equals 11, and for GL quads it is 2.75. Hence, I'm going to have only 2 quads. I'm going to have only 2 quadrangles. Similarly, I want you to find what is this going to be. Hence, so just think of this and just try to find what exactly the values and the formulas and the value you're going to get with respect to size. So this is all for this session. So thank you. And if you have any doubt with respect to this session, you can put it in the comment section, or if you want any clarity or any clarification you require from this topic, you can just let me know. Thank you.